All right, welcome everyone. Thank you for joining us. We will go ahead and get started, and I will let Professor Blaisdell introduce himself and get started with his presentation.
Thank you. So my name is Greg Blaisdell. I'm the graduate chair for the School of Aeronautics and Astronautics, and welcome to the research overview for the Gambaro Graduate Program of Aeronautics and Astronautics. So I do want to point out that I'm giving a very brief overview of each of the topics that are covered in our graduate program. So this is really meant to whet your appetite. I'm not going to be able to go into any depth, and I do encourage you to take a closer look at faculty members' websites who research interests line up with yours. So just to let you know about the events that are associated with our department that are going on today. So currently at 1 o'clock, I'm giving this research overview. There is a robotics research discussion that's at 2 o'clock in Zoom room 3. Because of conflicts, none of our faculty members were able to participate in that, but I do want to let you know that people in our department do work on robotics, mainly in the area of autonomy and control. And so if you go to that research meeting, you'll hear about some things that are interdisciplinary that are similar to what our faculty, some of our faculty are involved with. There is another information booth available from 3 to 5 where you can ask me and our graduate administrators questions about our grad program. And then there's a propulsion research review, including faculty from our department and mechanical engineering that'll be at 4 o'clock. So if you do have questions about our grad program, you can contact me as the grad chair, or Morgan Delaney, or John Brzezinski, who are our graduate program administrators. So our graduate program is divided into 6 different disciplines, but I do want to emphasize that we do a lot of interdisciplinary research, both among the disciplines within our own department and outside our own department. Students in our department would choose a major area and a minor area of study. So the areas in our department are Aerodynamics, Aerospace Systems, Astrodynamics and Space Applications, Autonomy and Control, which on our website you may also see as Dynamics and Control, which it was formerly known as, and then Propulsion and Structures and Materials. So again, I've got presentations from each of those areas that I'll go through. I'm not expecting a lot of time available for, at the end for questions, but there might be a few minutes left over. There are slides from those groups in 2 different formats. So unfortunately, I will have to switch back and forth between 2 different presentations. So in the aerodynamics area, this is the largest in terms of the number of faculty that we have. We have 11 faculty members. Alina Alexenko and does computational fluid dynamics and experiments on rarefied gas dynamics. Sally Bain does experiments in plasma dynamics and combustion. I do CFD research involving turbulence and turbulence modeling. Professor Stephen Collicott does experiments in low gravity fluid mechanics. Joe Jewell just joined us about a year ago, and he does experimental research in hypersonics. Sergey Mascheret does theoretical approaches and some experiments in plasma dynamics, and he leads our cold plasma preeminent team. You may notice plasma dynamics occurring with several of our faculty members, and that's because he leads a team that specializes in applying plasma flow control and plasma dynamics to aerospace systems. Professor John Pongi does CFD and used to do experiments related to plasma flow control and turbulence. Professor Steve Schneider does experiments in hypersonic transition. Professor Alex Shashurin does experiments involving plasmas. Professor Tom Shee does CFD involving turbo machinery and specifically heat transfer. And then Professor John Sullivan is in the process of retiring. This will be actually his last semester that he teaches, but he has expertise in experimental aerodynamics and then also pressure and sensitive paint as a way to measure pressure distributions and temperature distributions. So a little bit, a little bit more specifically, Professor Alina Alexenko does computational and experimental studies related to rarefied gas dynamics. that has applications to spacecraft in orbit in terms of looking at plumes for maneuvering spacecraft. It also looks at micropropulsion systems for small satellites, dealing again with rarefied gas flows that are appropriate for high altitude aerothermodynamics. Her research is also related to microelectromechanical systems where the length scales involved are small enough that you have to worry about non-continuum flow. May seem a little bit strange in an aerospace engineering department, but she also does research related to pharmaceutical processing because that's done in a vacuum environment where, again, low density rarefied gas flows are important. She's also developed computational techniques that are used in doing direct simulation Monte Carlo methods and Boltzmann equation solvers, again, looking at things from a molecular gas point of view. So Professor Sally Bain does research in experimental fluid mechanics that's related to using plasmas for controlling combustion, and then also using plasmas to do flow control. Over on the right is shown an experiment where she's trying to control boundary layer separation using plasma actuators. She also gets involved in using various diagnostic techniques that includes plasma flow analysis and looking at spectroscopy, PIV, and background-oriented Schliering as a way to do measurements of some of the flows that she studies. So let me go on then. My own research is related to turbulence simulations, using large eddy simulations or using turbulence models. I also do some turbulence modeling development and then apply that to various CFD related to aerospace engineering, depending on the projects that become available. Excuse me. So Professor Stephen Collicott does work in low gravity fluid mechanics, and he does a lot of work with commercial space flight companies. And so he'll work with our undergraduate and graduate students to design experiments that will then piggyback on suborbital flights to be able to study two-phase flows in a rarefied or in a small gravity environment. Again, that has applications to controlling fuel and slosh in spacecraft. There's a big problem if you don't have gravity to pull a liquid fuel down to the bottom of your fuel tank. You have to be able to come up with other means of managing how that fuel is going to go where you want it to. Sorry, I'm not sure why my presentation slides are skipping ahead. So Professor Steve Schneider is, I believe, not taking any further graduate students right now, but he is an international leader in hypersonic laminar turbulent transition. He was developed a quiet flow Ludwig tube that is a Mach 6 facility that produces very low noise levels in the wind tunnel. And the benefit of that is that it provides an environment that's very similar to flight. Professor Joe Jewell, who, as I said, has been here for 1 year, is going to be taking over that facility from Professor Schneider, and we'll be working with Professor Schneider in looking at mentoring graduate students in that area. Dr. Brandon Chenoweth is a research professor, and he is working with Professor Schneider to develop a new Mach 8 quiet tunnel. So again, Professor Schneider is kind of transitioning from being a professor who works with graduate students to be more of a resource for the Department of Defense, and then also a resource professor for Professor Jewell and Chenoweth as they get started on their research programs. Professor Tom Shih does computational fluid dynamics, and his work is related to applications involving propulsion systems, working with heat transfer inside turbo machinery. He's also done work with ice on accretion on airfoils, and then also two-phase flows dealing with transmission in powertrains for vehicles. Professor Sergey Mascheret is a theoretical physicist who has kind of transitioned into working in the field of aerodynamics. He leads the cold plasma preeminent team that is developing means of using cold temperature plasmas as a way to interact with fluid flows for flow control. So he works with basic physics of weakly ionized plasmas. Also, again, using plasma actuators as a means of controlling flow. And again, controlling boundary layer separation or controlling transition from laminar to turbulent flow. He also works with plasma antennas and switches. Professor John Pongi came to us several years ago from the Air Force Research Lab. He had a background previously as a grad student in experimental aerodynamics, but then transitioned when he worked for the Air Force into doing computational fluid dynamics. So he works on fundamental studies of compressible turbulent flows, transition from laminar to turbulent flow, shockwave boundary layer interactions. He also studies plasmas from a fundamental perspective, but then also looks at using plasmas for flow control as well. Deals with hypersonic flight, including non-equilibrium thermochemical reactions. So Professor Alex Shashurin also has a background in plasma dynamics. He deals with, again, atmospheric pressure, that is high pressure microplasmas, and how to generate them and how to use them for diagnostics and how to do diagnostics on plasmas. Looks at, again, using lasers to generate plasmas and then using microwaves to be able to do sensing of the characteristics of those plasmas. He teaches a course in electric propulsion. It's actually electric spacecraft propulsion. He does research related to that as well. And he also teaches a course in a plasma lab, again, teaching how to work with plasmas and be able to use them for flow control. And so a lot of people in the aerodynamics area. Our next area is aerospace systems. So the faculty members in this area are Barrett Caldwell. He's actually a professor in the industrial engineering department, but he has an appointment in our department by courtesy, which means he's allowed to supervise graduate students in our department. Bill Crossley is our department head. Dan De Laurentiis does research in systems of systems. And So Kwang does research in aerospace systems as well as autonomy and control. Professor Karen Murray does research in the area of reliability and safety. And then Deng Feng Sun is also another professor in autonomy and control that overlaps with aerospace systems. So again, aerospace systems is very broad and involves faculty in multiple areas. In fact, the faculty that are in aerospace systems also do research in other areas and are involved in other committees. The current members are listed down below that I just listed. The ones that are highlighted, Bill Crossley, Dan De Laurentiis, and Karen Murray are the core faculty in the aerospace systems area. Again, Professor Crossley, our department head, is also in the structures and materials area, but he does research related to multidisciplinary design optimization. So he teaches a course in design optimization. Dan De Laurentiis has overlap with dynamics and controls, or autonomy and controls, as well as astrodynamics and space applications. He does research really in systems of systems. And then Karen Murray she's our associate head for our undergraduate program, but then does research in systems as it relates to, again, reliability and control. So just a quick overview of what Aerospace Systems is about in the School of Aeronautics and Astronautics. About 15 years ago in 2006, it was established as a discipline, and really there were courses that were developed to help teach systems engineering, and it's really grew out of people who worked in the design area, but it's dealing with interdisciplinary challenges related to the design and managing and operating aerospace systems. Again, the faculty and students that work in that area really deal with integration, interfaces between different disciplines, and design, dealing with systems and looking at things from a systems perspective, dealing with safety and risk analysis, human interactions, things like that. Again, when we take a look at systems analysis, there's a Purdue Systems Collaboratory that extends across the university, involves multiple departments. Actually, Bill Crossley was the leader in establishing that collaboratory. Again, the research in this area is related to design and development and operation of aerospace systems. And there's an overlap between the research in systems engineering and the research in the systems collaboratory, and then also the educational aspect of teaching about systems engineering. I'm going to, for the sake of time, skip through some of these slides. So systems engineering deals with complex systems, such as aerospace systems like launch vehicles and aircraft and air traffic control systems. But then it also deals with something more complex, which is systems of systems. That is where you've got very complex networks of independently operating systems that have to deal with interacting with each other. And so how do you deal with that complex interaction involving complex systems? Okay, so again, some of the specific areas of research that our faculty work on are related to air transportation, related to modeling and analysis of systems, dealing with multidisciplinary design optimization, and then also dealing with system safety and reliability. Okay, I'm going to have to switch presentations now to look at astrodynamics and space applications. All right, so the astrodynamics and space applications. The core faculty members here are Professor Carlin Free, and then Professor James Garrison and Professor Kathleen Howell and James Lunguski. There are other faculty members that are involved, but these are the 4 core faculty members in that area. Professor Carlin Free is on sabbatical this year, so if you do email her, just realize that she's on sabbatical. She will respond to email, but it may take a while to respond. So Professor Free's area of interest is space traffic management, dealing with space debris, as well as active satellites that maneuver. She deals with using optical techniques, such as the satellite, or I'm sorry, the telescope that's shown here. And then the movie playing over on the right is where she's tracked a set of satellites, and you can see the background stars moving behind where the satellites are being tracked. But she deals with using optical techniques, often ground-based techniques, to be able to characterize vehicles in space and to be able to track especially debris in space, because that is a real concern for people who want to then operate in low Earth orbit. Okay, so again, part of not just tracking, but also characterization of vehicles in space. Again, using optical techniques and a lot of statistical and physical analysis. She's actually has a background in astrophysics and is able to use some of that understanding to then be able to characterize in detail what kind of vehicle it is that is being viewed. Professor James Garrison works in the area of remote sensing and satellite navigation. He's done a lot of original work related to using signals of opportunity where the navigation satellites that provide GPS and other signals, those signals can then reflect off of the ground surface, off the surface of the ocean, actually penetrate to a certain depth within the ground, and then to be able to be reflected back to space where they are sensed. And you can back out information about the state of the ocean, about the state of the atmosphere, or about the state of the ground, and do a lot of work in applications related to that. So he has also worked with people in environmental engineering and with earth and atmospheric sciences, again, to be able to use remote sensing as a means to characterize what's happening on the Earth. So this just gives a few examples of his interactions with related to, again, ecological and environmental engineering, and also dealing with earth and atmospheric sciences. I also will say that he deals a lot with developing hardware as well as software for doing these kind of analysis. He did a lot of work with the Snoopy program from NASA that used a set of small satellites to then sense the atmosphere and do remote sensing. Professor Kathleen Howell has a lot of experience working with NASA's Jet Propulsion Laboratory and designing trajectories for spacecraft. And she has designed a lot of the trajectories for deep space probes. And these are just a few examples of the spacecraft trajectories that, that her and her students have worked on. For her own thesis, she worked on halo orbits, which are a kind of orbit around a Lagrange point between the Earth and the Moon, or on the where the gravitational forces from the Earth, Moon, and Sun are balanced, and that you can orbit around a Lagrange point. And that kind of orbit is now being considered as a means of developing infrastructure as a stepping stone towards going back to the Moon and eventually going on to Mars to develop, again, space infrastructure that would use a halo orbit around a Lagrange point. These are just other examples of some of the spacecraft missions that Professor Howell and her students have been involved with. Professor Longuski also works on spacecraft trajectories. He's worked a lot on trajectories and mission planning for, say, going to Mars. He's interacted a lot with Buzz Aldrin, who was the second person to land on the Moon and to walk on the Moon. And in working with Buzz Aldrin, they have published a means of being able to effectively go to Mars efficiently. And again, they've worked together, and he's worked with both his undergraduate students in design courses and his own graduate students in planning missions, and then also doing trajectory analysis for deep space probes as well. He's written 3 books related to aerospace engineering that are listed down at the bottom. This is, again, just some of the thesis titles that Professor Langusky's students have written, just so you can get a rough idea of some of the types of analysis that he and his students do. Quickly kind of go on after that. Okay, so it's time to, again, sorry, but switch back. Okay, so the next area to discuss is autonomy and control. Again, this used to be dynamics and control, but autonomy and control is related to looking at control systems to provide students with a solid background in fundamental control theory, as well as applications for autonomous systems related to aerospace engineering. And so you can also take control systems and relate that to the process of a faculty member providing input to students that would, or students coming in, being processed by a system that faculty members are involved with, and then many years of feedback control to then gain an output at the end. That's the process of then developing not a PID controller, but a PhD controller. So Professor Art Frazo works in the area of control theory. So he has a background in electrical engineering and mathematics and applies that to various types of control theory, accounting for uncertainty through looking at fundamentals of stochastic processes. And again, he's got a very rigorous theoretical background. Professor Martin Corliss has done research and teaches courses in optimal control theory, networked systems, and robust control in the presence of uncertainty. And they've also developed several textbooks. Professor Dan De Laurentiis, who's in the aerospace systems area, also interacts with applying systems analysis to control systems. So I'm just going to kind of briefly skip over this, but he does work with, again, interactions of control theory with systems analysis. Professor En-Sook Wang does research in control theory applied to cyber-physical systems. He deals with cybersecurity and then high assurance control related to aerospace systems. He's involved with development of a test bed that is going to be run in a facility out at the airport where they're going to be able to test unmanned air vehicle systems. And again, he does research related to the interactions and control of those unmanned air systems, and then also has done research related to air traffic control. Professor Dangfeng Sun also does research in control and optimization. So he teaches a course in convex optimization. He applies mathematical theory and develops algorithms related to control of aerospace systems involving networked vehicles, and then deals a lot with air traffic control systems and trying to develop, again, mathematical and algorithms that can be applied to that. Deals with very large scale optimization problems, and again, has developed some unique, fast, and widely well, applicable algorithms for doing that large-scale optimization related to controls of systems like this. Again, a lot of his work is related to air traffic management. Ron Dai is a new professor who just joined us this semester. She has worked previously and is continuing to work in autonomy of solar-powered air and ground vehicles. She works with optimizing trajectories for entry, descent, and landing of, say, spacecraft like going to Mars. She has also worked on hybrid systems and unmanned aerial systems, and in working on missions where say the solution for a control problem actually ends up, the optimal solution ends up changing during the process of the mission, and how to deal with systems like that. And then she also works with learning-enabled optimal control, getting into some things related to machine learning. Professor Xiaoshui Mao deals with autonomous and intelligent multi-agent systems. And so he works again in control and optimization, but related to multi-agent systems that have to interact with each other, where they have some autonomy, but then again end up interacting with each other. He also deals with machine learning and relating that to the control of these networked systems. He deals with doing control theory for swarms of, say, large numbers of small vehicles that would be able to interact as a group and not just individually. He also deals with human-in-the-loop control of, again, large multi-agent systems. A lot of his work is theoretical. However, he also does some experiments and has a laboratory where he's testing out some of these control algorithms on real small-scale flight vehicles. So I mentioned Professor In-Suk Huang, and then also Dr. James Scopert, who's a visiting professor in our department, or actually a research professor in our department, are working on developing a facility in one of the hangars at the airport that's located next to Purdue. We are one of the few universities that has an operating airport, but that facility is going to be turned into an indoor motion capture environment for studying UAS. And it will be the largest indoor facility in the world once it gets developed for that. Okay, so next is propulsion. Excuse me. Sorry. So there's several members in the area of propulsion. Professor Bill Anderson, Jay Gore, who's from mechanical engineering, is a professor by courtesy. Steve Heister, Nicole Key is also from mechanical engineering. Bob Lucht has a joint appointment from mechanical engineering in our department because he is the director of Zucro Labs. Tim Pourpoint, Li Xiao, Carson Slabon, and then Steve Sun is from mechanical engineering, and then Haifeng Wang. So just, sorry. Just briefly, certainly each of these faculty members does a lot of research in a lot of different areas, but I've just kind of picked out the one or two things that really stands out for what they're known for. So Bill Anderson does a lot of work on experiments of and analysis of combustion instabilities. Jay Gore does basic combustion science. Steve Heister does work in rocket propulsion. Nicole Key does work in turbo machinery. She has a compressor lab. Bob Lucht is the Zucro director, and he does research in laser diagnostics and combustion. Tim Pourpoint does rocket combustion and works with hypergolics, which are, say, two chemicals that you can put together and they will react immediately upon touching each other. That's very useful when you worry about ignition for propulsion systems. Having hypergolics is a mean to initiate that ignition. Li Xiao works in alternative fuels. Carson Slabon does chemistry flow interactions and works with rotating detonation engines. Steve Sun works mostly on energetic materials. And Haifeng Wang does turbulent combustion modeling, a lot of CFD analysis related to reacting flows. Yeah, I do want to point out that Zucro Labs is one of the largest, well, it is the largest university propulsion lab in the world. There's going to be a special propulsion research session this afternoon at 4 o'clock in Zoom room 3. And I'd encourage you to look at the details of the propulsion research that's done both in mechanical engineering and our department, Aeronautics and Astronautics. Again, there's a link there, but you should be able to join that. So I did want to point out that Professor Steve Heister, Bill Anderson, and Tim Pourpoint were co-authors on a book published by Cambridge University Press that just came out last year on rocket propulsion. Okay, so again, I need to skip over to the other slide format, excuse me. Right, so the last group to discuss is structures and materials. And there's several members here that can actually spend over a couple of pages here. So Dr. Wayne Chen is a professor in the structures and materials area. He's also the associate dean for the College of Engineering for Research and Innovation. Bill Crossley is our department head. James Doyle works in, again, structures and materials. Dr. Byron Pipes works actually in 3 different departments. He's partly in our department, partly in chemical engineering, and partly in materials engineering departments. He's a member of the National Academy of Engineering. I'll describe his research in just a few minutes. And then Dr. Michael Sangid, again, is I think recently promoted to full professor in our department, and then Tyler Tallman as well. And then 2 last members are Vikas Tomar and Wenbin Yu. So one of the facilities that Purdue has that you should be aware of related to structures and materials is the Indiana Manufacturing Institute. It's a very large facility where they work on manufacturing methods for composite materials, including additive manufacturing. Again, it's almost a factory level manufacturing facility where they can test out different manufacturing methods. And Dr. Byron Pipes is the director of that. Dr. Wayne Chen, well, so first of all, besides that large lab, there are also several individual labs. So the Impact Science Lab run by Dr. Wayne Chen, the Advanced Computational Materials and Experimental Evaluation Lab by Dr. Michael Sangid, the TNT Lab with Tyler N. Tallman, and then the Interfacial Multiphysics Lab with Vikas Tomar, and the Multi-Scale Structures Lab with Wenbin Yu. So Dr. Chen does a lot of work on high impact responsive materials, dealing with developing, say, body armor and armor for vehicles, as well as just characterizing materials based on high impact loading. Again, Professor Bill Crossley has a background in structures and materials, but most of his work is related to multidisciplinary design optimization and really deals with more aerospace systems now. Dr. James Doyle teaches courses and does research in the area of analysis of structures dealing with wave propagation and in structural material, and he's again written several textbooks related to that and developed computer programs that are related to analysis of structural materials and characterization of their properties, and then, as I said, dealing with wave propagation and solid mechanics.
Professor Blaisdell?
Yes.
You have about 5 minutes.
Thank you.
You're welcome.
So Professor Byron Pipes, as I mentioned, he's the director of that research facility that I showed at the beginning. And his major areas of research are developing from both a fundamental and then also practical level, dealing with understanding of composite additive manufacturing, and also looking at, as I said, how on a practical level to design and assemble additive manufacturing systems, and then also looking at computer simulations to be able to characterize their properties. And again, dealing with large-scale facilities to be able to test out some of those research ideas. Professor Michael Sangid does basic research that also has very practical applications. So he looks at modeling materials from the molecular state on up to larger length scales, and deals with, again, looking at characterization of materials, and then developing models of those materials. And a lot of his work has been highly cited, and then also a lot of his work has been very useful in, again, making predictions of behavior of solid mechanics, looking at things like failure and fatigue, and very important work that's being done there. Professor Tyler Tallman deals with smart materials, that is, materials that can kind of change their properties based on what's needed for the application. He also works in, say, sensing of materials to back out their fundamental mechanical properties, and then also looking at non-invasive image characterization of materials. Teaches a course in non-invasive characterization of solid mechanics. And again, his lab is kind of the overlap of those three different areas. Professor Vikas Tomar does a lot of research related to interfacial multiphysics in solid mechanics, and deals a lot with very say, extreme environments, such as during an explosion, and is able to use experimental, but then techniques to to be able to characterize interface interactions, dealing with again solid materials during under extreme conditions like this. Dr. Wenbin Yu has developed a set of software that's actually offered commercially to then deal with design and manufacture of solid material that again goes from very small scale, micro scale understanding of the structural mechanics of the material to all the way up to where it's being used to manufacture things. Okay, let me skip back to the other presentation.
You have about 1 minute left.
Okay. Yeah, so I just kind of wanted to finish up with a little bit of funding, resource, and advice. So, and I should say, if you are interested in any of these research areas, I'd say before you contact a faculty member, please do a little bit of homework. That is, look at their website, maybe even read some of their papers to get some background information before you contact them. If you go to our graduate program website, there's a link to admissions FAQs, frequently asked questions, and there's some specific questions that would be related to how do you go about contacting faculty members if you're interested in working with them. I'd encourage you to look at that. There's also some other links that are available on our website, the College of Engineering, and the grad school's website related to funding as well. So I might have time for one question. I know that I went through a lot of material really fast, but that's just meant to, again, give you a really quick overview of what's going on in our department. So I was wondering if there's any individual questions that something important that stands out that I might be able to answer.
I'm not sure if Ashley's on here, but I don't see any in the chat. There was one that we responded to there, but otherwise I don't see any at this moment.
Okay. So again, I would encourage you to take a look at individual faculty members' websites to learn more information about what they're doing, and then do some background homework before you contact them. Also, please be patient. Faculty members are very busy, and then with COVID, we're having to do a lot of new things differently. And so it may take a little bit of time to respond. But I'd also say, give them a couple of weeks and then maybe follow up if they haven't responded to you. Be patient but also persistent in reaching out to faculty members.